Part 1. Radiant energy. Any energy, including heat, light, and X-rays, that are transmitted by radiation. This occurs in the form of electromagnetic waves. A photon is, in a particle model of an electromagnetic radiation, a particle that travels only at the speed of light and whose energy is related to the frequency of the radiation in the wave model. An electromagnetic wave. It's a wave that is partially electric and partially magnetic and carries energy, emitted by vibrating electric charges. Examples of this are all the waves on the electromagnetic spectrum. The electromagnetic spectrum is the range of electromagnetic waves, extending from radio waves to gamma rays. Examples of this are X-rays, microwaves, gamma rays, infrared, radio waves, visible and ultraviolet light, also known as visible light. This is electromagnetic radiation that produces a visual sensation. This is when we see any color because the colors in the rainbow get absorbed into something, except for the color that it is. This also occurs when we see anything at all because light is bouncing off of objects and bouncing right back into our eyes. Part 2. The electromagnetic spectrum is a continuum of all electromagnetic waves arranged by their frequency and wavelength. Electromagnetic waves are created when electrons move and create a magnetic field. Then the electrons move back and forth, and their electric and magnetic fields change together, causing an electromagnetic wave to form. The speed electromagnetic waves travel through a vacuum is 3.00 times 10 to the 8th power meters per second, a speed value commonly represented by the symbol c.
The dual nature of light is a theory that suggests light has characteristics of a wave in particles called photons. The energy that a photon has is able to cause it to behave like a wave or a particle. The difference between electromagnetic waves and mechanical waves are that mechanical waves require a medium to travel and the electromagnetic waves do not. A similarity between the electromagnetic waves and mechanical waves are they both include general properties of all waves. Frequency, wavelength, and energy change in the electromagnetic spectrum because when you move towards the infrared, radiation, and radio waves part of the spectrum, the energy and frequency decrease. When you go towards the gamma rays, X-rays, and ultraviolet, the energy and frequencies decrease. For wavelength, when you go down to the infrared, radiation, and radio waves part of the electromagnetic spectrum, the wavelength decreases. In gamma rays and X-rays and ultraviolet rays, the wavelength decreases. The frequency of X-rays are from 3 times 10 to the 16th Hertz and upward. The wavelength range is from 10 nm and downwards. The range of energy levels are from 124 eV and up.
X-rays are given off by colliding high-energy electrons against a metal target in an evacuated tube. X-rays are produced whenever fast-moving electrons are decelerated, not just in X-ray tubes. X-rays are used to help doctors find broken bones. The light passes through the skin, and when it gets to the bones, it slows down and gets refracted. The light makes the skin appear darker than the bones or area in the body that is being examined. It is also a tool used to search luggage at an airport and to examine teeth. It is also used for capturing an image of the stomach to see if an object that may harm the body has been swallowed. Some fun facts about X-rays are: physicist Wilhelm Conrad Roentgen discovered them accidentally in 1895 while he was studying cathode rays. He called it X radiation to indicate that it was an unknown type of radiation. In many languages, X radiation is called Roentgen radiation. X-ray star binaries pump out 1,000 times as much X-ray radiation as the sun does. X-rays reach the Earth from outer space.